So we're looking at our lock contract, and let's say we wanted to add a little bit of functionality to it. Maybe we'll treat it like a piggy bank where you can only withdraw after a certain date, but you can add more money to it whenever you want. So let's add a function called deposit. And this won't need any arguments because we'll make it public and use the payable keyword, since our contract design has the contract itself hold the balance that's in deposit. We do want to make it so that the user can't accidentally deposit funds after the withdrawal date. So we'll add a require and say that block.timestamp must be less than or equal to our unlock time. Or you get a message, you can't deposit after unlock. And then maybe we don't want our users to accidentally deposit funds into the wrong piggy bank. So we'll require that the message.sender is the owner. And we'll give the message, you aren't the owner. Finally, we can see that an event is emitted for withdrawal. So let's add one for deposit. We'll say event deposit. And that's going to have a uint for the amount and a uint for when, the same as withdrawal. Finally, we need to go back down to our new function, and we can emit that event with emit deposit message.value and block.timestamp. So we've written a new function. We should write tests for it as well. So we'll go over to our lock.ts test file. And after being able to receive and store the funds to lock, we can add in a new test that should allow additional deposits. And we'll want to call our new function. But you'll notice if you try to write lock.deposit, our new function is missing. It's not present in the IntelliSense, which is unfortunate. And the reason for that is we haven't recompiled the contract. So it's related to the compiled version and the compilation process that Typechain does its magic. So let's go back down to our console and run npx hardhat compile. And we can see that we can now say lock.deposit. Finally, one thing we want to take a look at while we're here is up at the top of our test file where it creates the fixture that does the setup for every single test and essentially recreates the contract and redeploys it on the blockchain so that it's fresh and unmanipulated and you can get predictable test results. Although bear in mind that that could also lead to unpredictable test results if you're expecting things to still be there each test. And if we look here, we can see that we have an owner and an other account, which are using a library called ethers and a function called getSigners. And so these are essentially wallets or accounts that are used in testing, and we can use them to do things like make sure that the other account is not able to withdraw the funds that belong to the owner.